We're going to get started with the quality chapter. We're going to talk about the quality. Now, when I prepared for my PMP examination at that point of time, my strength was quality. I was already a master black belt, so my strength was quality and risk management because I had already had the MOR, management of risk, at that point of time. Now, with that, if you are able to identify what is your strength, focus on your strength. This would ensure that you are, for sure going to get the complete points in that particular chapter. For example, if your strength is mathematics, focus on the mathematical questions. If your strength is quality or risk, pick up any one area which is your strength and focus a lot on that chapter. That helps ensure that you cover the bare minimum points which is required to clear the PMP, the project management. Uh, as I said earlier, from initiation and closing, there will be around 21% of the questions which will come from there. So all that you require to get apart from that is 40%. 21% from the initiation and closing is kind of guaranteed. Those are very, very simple questions. Then there are a couple of questions from ethics, right? Those are also very easy. Those are not too difficult. We just have to ensure that we don't answer it from a real life perspective. We don't answer it from what we would have done in our organization, because at times, a lot of times rather, we compromise on ethics and without even realizing it, without even realizing that we're compromising on ethics. So that is one thing which you would be able to answer it properly. If in case you get away from the real life situation and think that you're a project manager of that Palm Janeiro Island, the video which I showed it to you, right? So ethics has also become very simple. The initiation, the closing is simple. Identify any one or two strengths and you should be able to easily clear your examination. Now, quality management chapter, when we talk about quality management, there are two things which we have, rather three things which we have to speak about. What is quality? Let's define quality. Now, a lot of people, in their mind somehow, the perception about quality is it's probably, overly shining product, the product which is, this is how we often think in our minds that the quality means. Quality probably means something which is, if you compare two products, one product which looks better, right? That's not what quality is. Quality is, customer has given me a specification. Customer has given me a specification of, that has to measurable specification. Meeting customer's specification is quality. If I'm not able to meet the customer specification, I'm not delivering a quality product, right? So for quality from the PMI perspective is, or rather the true definition of quality is just meeting your customer's expectation, nothing more, nothing less. I don't want us to deliver anything additional to the client just to keep him satisfied, because in between there were a couple of instances where client escalated. So just to keep him satisfied, just to give him something extra, we over delivered. No, that's absolutely a big no-no from PMI perspective. We are not going to do any scope creep, no gold plating, right? There is no other additional things which will be adding up for the client. We will deliver what the client wants, right, throughout the life cycle of the project. That is quality. Conformance to requirement is quality. Fit for use, fit for purpose, that is another definition of quality. Fit for use, it should be fit for use, and fit for purpose, whatever purpose the product or the project was envisioned or started up. So fit for use, fit for purpose, and conforming to the requirement becomes a quality. Now, in quality, we often use two terms, that is precision and accuracy. What is precision? What is accuracy? Now, this is another thing which often gets very confusing. Precision and accuracy, they're confused, and we often think these are the same thing. So let me try and explain it. Let's say this is, I won't be able to do a very good job in drawing that dartboard because I'm not very good at drawing it in a screen. But let me try to show that, do a little bit of illustration here. Now, assume this is a dartboard. Quite crooked dartboard though, but yeah, let's assume this is a dartboard that we have. If we are hitting it every time, the dart, if you're hitting over here towards the left, if you're hitting every time and it's, every time we are making the same mistake. We are supposed to hit in the center, but every time when we hit, it gets, the dart comes and hits over here. So after a point of time, if you look at all the dots, it is centered somewhere towards the left side of the um, of the bullseye, of the center of the dartboard. Now this is precision. You are not accurate, you're not hitting a bullseye, but you are very precise. You're hitting right wherever you're hitting absolutely correctly, right? If your data is here, right, in this center, clustered in the center, that would mean you are precise, both precise and accurate. So here precision is also there and accuracy is also there. You are very precise, you don't have a high variation, the variation is low, and the accuracy is also there, you're hitting right in the bullseye. Now, again, the same example, if I have to expand a little bit, if you're a newbie and trying to hit the bullseye, maybe sometimes you would be able to hit the bullseye, but a lot of times you're hitting towards the other side. Now, this is where on an average you're hitting the bullseye, but there's a lot of variation. So this is you're accurate but not precise, right? So this is the difference between the accuracy and the precision. There are three processes that we have in the quality management. One is plan quality management. We first have to plan the quality management. That is, what is a plan document? Always remember, whenever we talk about the plan document for any knowledge area, it is what are we going to do and how are we going to do. That is, what are the tools and techniques that we will use to manage quality inside my project? If there is any deviation, how would I take care of it? How would I do the root cause analysis? How would I do the corrective action and the preventive action? um, any change to the quality management plan, how that the plan will be built up or how that would be taken up, right? So all that will be mentioned in the plan document. Then I need to get it approved. I will get that plan approved and will execute whatever is mentioned in my plan document. So execution is you perform your quality assurance. So you go and perform your quality assurance. There is a difference between quality assurance and quality control. Quality control focus a lot upon your deliverable, whatever you're supposed to deliver to the client. So it focuses a lot on the deliverables. Quality audit is about finding out if you're following the procedure which was laid down by the organization to build whatever the customer wanted, right? So quality audit is focused on the procedures and the policies and the procedures and conformance to those policies and the procedures. Quality control is where you build the test cases, try to find out if you're building whatever the client wanted. And eventually we need to find out if we are delivering whatever the client wanted and my quality program or the quality management plan is working effectively. If not, I need to control it. I need to find out if it is not working correctly, then I need to make changes to it. So it's a process of managing the project quality in the defined tolerance limits, control limits and ranges during the project execution. That is the control quality. Let's talk about a couple of terms in quality management. These terms often come in the examination, so we need to remember them. What is customer satisfaction? It is if you are meeting the customer's requirement or not, and customer is happy about it or not, right? Customer is content with the deliverable or not. So ensuring that the project requirements are met, and at the same time ensuring the project outcome is usable by the end user or the client, and the customer is content with the outcome. Prevention over inspection, this is another very important concept where we don't want to inspect, we want to prevent the defect from happening. Now, I was doing one consulting work for one of the company. This is a company which manufactures the parts for Boeing and Airbus. Sometime back, they invited me to do consulting work for them because the cost was spiraling up. Now, Boeing and Airbus, they wanted to reduce the cost, and this guy was supplier for them. They had huge cost pressures. Boeing and Airbus wanted to reduce the cost, so they had huge cost pressures on the supplier. Supplier invited, and the first thing which I noticed was because of the quality standards of Airbus and Boeing, they were inspecting each and every part. Inspecting each and every part, what is the problem in it? It's good, right? There's no problem in that. If you're inspecting each and every part, that means that you will not be delivering defects to the client. However, the problem here is for each part, now the labor cost has just doubled. Initially, whatever your labor cost was there to build it, now you have to increase that labor cost, almost double that labor cost, because you have to monitor each and every part now. Versus if you have to monitor only a sample, your cost goes down. Drastically, it goes down. Imagine you monitoring, billions of parts versus just a couple of thousand parts that you have to monitor. Now your requirement goes down drastically. this is where, and to ensure that you're monitoring only a sample, your predictability in the in the entire process has to go up. You should be sure that you're not producing defects. Once you have made the process so capable that it's not going to produce defects, you just need to monitor the sample to understand if your process is deviating, to understand where the process is heading. As soon as the process deviates, you have to stop the production line to find out the cause, eliminate that, and just keep on monitoring the sample, right? To ensure your process is not deviating to from wherever you have set it. That is the importance of prevention over inspection. You need to prevent the defect from happening rather than inspecting it. Next is continuous improvement. So continuous improvement is, it's a methodology where we continuously try to make improvements over the processes. Now there are a couple of methodologies that we have: plan, do, check, act. Our entire um, project management is based on this plan, do, check, act cycle, which was proposed by Deming, Mr. W. Edward Deming. Total quality management is a methodology which was started in manufacturing. So this has come up from the manufacturing part, total quality management. Six Sigma, this helps you reduce the variation. Remember the precision. If you have too much of variation in the process, you would say you are accurate, but you are not precise. You want to ensure that you are producing every time whatever the customer really wants with very less variation, with very less, with almost precision. So that is what Six Sigma focuses on. Increasing the precision is what Six Sigma focuses on. Lean Sigma is about eliminating any unnecessary, any unnecessary wastages, any unnecessary step within the process which is not adding any value from the customer perspective, right? So that's about Lean Sigma. Now, Lean Sigma, let me give you an example of that. So if, let's say, you're traveling to office in your car, and somewhere on the way you have a flat tire. So what would happen? You need to go and change the tire. How much time it would take for you? Probably 15 minutes, 20 minutes, half an hour at the best, right? So you won't be, even if you have help, the least that you would require is around 10 minutes. Now take the same example to Formula One racing. They have optimized the process to such an extent that within a couple of seconds, they replace all four tires of a car. How is that possible? Because of the optimization that they've done, they've eliminated all the unnecessary steps which was not adding any value. Yes, they have more more labor available with them, but at the same point of time, they are replacing all four tires. They've eliminated all the wastages, all the non-value added steps out of the process to reduce the time frame. That is what Lean Sigma helps us do. Kaizen is continuously keep on altering your process to make it better. So when we say that, whenever you have a problem in your organization, if you have a solution towards it, go ahead and implement it. That's referred as Kaizen. Continuously keep on altering it. When you have a problem, when you don't know the solution, that is when you do Six Sigma. That's the only difference between Six Sigma project versus the Kaizen. Kaizen is you have a problem, you have a solution, go ahead and implement it. Let's talk about continuous process improvement, that is CPI. Now there are two there's a difference between continuous improvement and continuous process improvement. Continuous improvement could be about inside the project, you improving the delivery of the project. So initially you planned something, then you understood that maybe your plan documents are not working effectively. You refine the plan document for the same project. Continuous process improvement is improving the process of conducting the project itself, whatever project it might be. So it's the same thing, right? Quality control versus quality audit. Quality audit is where you're trying to find out if you're meeting the organization's policies and the procedure. The procedure of the organization, is it effective or not? That is process, which needs to be enhanced. That's a process improvement. Now, in the organization, I'm sure you would have heard about, since you're from the software background, you would have heard about CMMI, that is Capability Maturity Model Integration. There are CMMI level 4, level 5 companies, which gives more confidence to the clients to give the contract to them, because these companies give some sort of predictability to the customer, some sort of confidence about the predictability of their programs to the customer. Similarly, capability maturity model is for services and for development. Similarly, for projects, we have OPM3 from PMI. which is organizational project management maturity model. Management responsibility, in your organizations, I'm sure you would have seen, if you ask people to follow the procedure, they won't do it, right? So if you leave the procedure following to people, you don't monitor it, people won't follow the procedure. Very simple example of that is in India. I'm sure I have not seen that thing in when I was there in US, but in India, how it happens is if wearing a seat belt, wearing a helmet, it's mandatory. It's otherwise offense, and they fine the rider, the person who's driving a car or a two-wheeler. Now in India, unless somebody is watching them, they will not wear the seat belt, they will not wear the helmet. This is for whom? This is for them. If something happens, they would die, but still they will not wear it. And what's going to happen? Nothing. Probably just wearing the helmet, their hairstyle probably is going to be a problem. This is no impact, right? But still they're not going to wear it because um, I mean, it's my wish. Why should I wear it? Why should I follow the procedures? Normally, humans tend to deviate from the procedures. They are rebellions. Humans are rebellions. They don't want to follow procedure unless it is top down. It is driven by authority. That is why we say that quality is never a bottom-up approach. It is a top-down approach. Management has a responsibility of driving quality in the organization. Otherwise, the quality will not be driven in the organization. Next is International Organization for Standards, which talks about, yeah, International Organization for Standards has given ISO 9000 certifications where organizations get certified for quality management structure. The entire program of quality management chapter in PMI is completely aligned to ISO standards. Let's talk about the three quality approaches, the three quality gurus, the approaches of quality proposed by three gurus. This is one I want you to mug. I want you to remember it completely because at least one or two questions will come out of this. How the question will come is, who has proposed the triology, right? Who has proposed the triology? It is Joseph M. Juran. Quality planning, quality control, quality improvement is Joseph M. Juran's triology, right? So this is how the question will come. Now this is something which you can understand, but you won't be able to remember that who proposed it till the time you mug it. So that's something. This slide is very important. You need to completely by heart this slide to be able to answer the expected 2 or 3 questions out of this particular slide. W. Edward Deming, he proposed the continuous process improvement. So he said that organizations can increase the quality and reduce the cost by continuous process improvement. Joseph M. Juran gave 80-20 rule, which is Pareto, and also developed the Juran's triology, which is planning, control, and improvement. You plan it, you control the quality, and then improve on it on a continuous basis. Philip Crosby, he proposed the DERFT, which is doing it right the first time. And he also proposed 4 major principles of quality, which is quality is conformance to requirement, system of quality is prevention, performance standard is 0 defects, and measurement of quality is price of non-conformance. Again, from the exam perspective, it might be given to you saying that who proposed system of quality is prevention? That is Philip B. Crosby, right? So that's how they would put the question in the examination. All right, so next is, let's talk about the plan quality management. When we're planning the quality management, what are the things that we need to consider? So when we're planning the quality management, we have, we need to understand that what are the different tools and techniques which I want to use inside my, when I'm executing my project at that point of time, what are the different tools and techniques which I want to use to first of all understand what are the defects which are happening. If the defect happens, how would I be able to control it? How would I be able to find out the root cause behind it? How would I be able to eliminate that root cause? How would I be able to prevent it from happening in the future? Take the corrective action and then preventive action, which is also referred as CAPA, right? So what are the different tools and techniques which I will be using? How will I be doing the audit? How would I be doing the control? right? So all these things has to be planned. These are different tools and techniques mentioned over here. These tools and techniques mentioned over here are not that you would be using all the tool and technique. Whichever tool and technique fits your environment, fits your project requirement, you would use it. And whichever tool and technique doesn't meet your requirement, you won't use it. And also, you might not be using any of the tool and technique mentioned over here. You might be using something else. For example, regression is not mentioned over here. You might want to use regression. So, it's just an indicator that about some of the tool and technique which is available in the market. You want to use something else, go ahead and do it. You want to use all these, go ahead and do it. You want to use some of these, go ahead and do it. Depends upon the environment of your product, of your project. So what are the tools and techniques we have? Cost benefit analysis. When we are planning quality, we need to ensure that we are planning quality. Quality is a cost, right? We are adding some cost to manage the quality, to understand the quality. Quality manager, QCs, these are additional costs, right? So they are not adding, or they are not really developing the product or the service for the customer. They are just validating if whatever we are developing is meeting the customer's expectation or not, customer's requirement or not. This is additional, this is additional cost which the customer is not really ready to pay for. The customer is not ready to pay for this. Customer is ready to pay for a product which is meeting its expectation. Doesn't matter how do you produce it. Doesn't matter if you audit or not. It has to meet my requirement, right, as a customer. So there is a cost which is there. What is the benefit that is coming out? You need to analyze that. You're investing $100,000 by hiring probably your quality managers, quality team, and what is going to be the benefit out of it? Maybe you expect $120,000 worth of less defects happening because of it, right? So it has to make sense to have a larger quality team, or whatever quality investment that you're doing. It has to make sense from the budgetary perspective as well. Cost of quality and cost of poor quality is another one. So what is the cost of quality which I'm incurring, which is how many number of people I'm hiring, what is the tool and technique that I'm incorporating, that is cost of quality. Cost of poor quality is where I have a defect. Now to get it rectified, to get it eliminated, to get it corrected, that is cost of poor quality, the additional cost which has happened because of me producing something of poor quality. We will also talk about 7 basic quality tools in a short while. So 7 basic quality tools is going to explain to me about, how do you identify the root cause of a problem? How do you go ahead and, have any kind of relationships built between the root cause and the outputs that we have, so that you can control it. Then we will talk about the benchmarking, which is comparison of apples to apples. Design of experiment, hold on. We will talk about design of experiments in a short while. Statistical sampling, additional quality planning tools, and meetings. These are the tool and technique which we have in the plan quality management. So cost benefit analysis is the cost divided by benefit, right? That is CBR. BCR is benefit divided by cost. From exam perspective, they will say that the CBR for the project is, for a given project that you're working on, when you calculate the CBR, it comes as 2. Is it good or bad? CBR has to be lower or equal to 1, right? Otherwise, it is not good. That means your cost is higher, benefit is low. If your BCR is greater than 1, that is good, right? So other way around. They tend to confuse you with this term. It's just that CBR is cost divided by benefit and BCR is benefit divided by cost. That's how the BCR is calculated. Next, we have the 7 basic quality tools. Let's talk about the 7 basic quality tools that we have. 7 basic quality tools is, first is cause and effect diagram, flow charts, check sheet, Pareto, histogram, control charts, and scatter diagrams. Let's talk about each one of them. This is the cause and effect diagram. Cause and effect diagram is also referred as Ishikawa fishbone diagrams. This is the other names of cause and effect diagram is Ishikawa diagram or fishbone analysis. Why it is called as fishbone analysis? It looks exactly like fishbone, right? And why is it called as Ishikawa? Because it was proposed by Dr. Ishikawa. And this is also referred as cause and effect diagram because it talks about what is the effect, what exactly is happening in the project, what negative effect is there, and what was the cause of it, right? So that's what it gives me the details for. Flowchart is the process flowchart that we have. So I'm sure you would have seen multiple times the process flowchart that we have, how the entire process starts and where the process ends. Check sheet is, it talks about the frequency of the defects that we have along with the, along with the weightage for each of the defects. So we can give the different weightage to each of the defects, and this helps me prioritize the defects with higher weightage and higher frequency. Pareto diagram talks about 80-20 rule, which is 80% of the defects happen in the organization or in the project because of top 20% of the contributors, top 20% of the defects, top 20% of the errors, 80% of the problems in your project are happening because of top 20% of the defects. Control these top 20% of the defects and your project will have 80% of the benefit achieved, right? So that's a theory which was rolled out, and that is how it was prepared. Now, whenever we do the this again is a prioritization tool, so this helps me prioritize on the top 20% of the defects which is causing maximum problem in my project. It doesn't mean that exactly the ratio will be 80-20. It will be, for example, it would be 22% of the defects contributing to 80% of the problem, and vice versa, right? So it's approximation. Histogram is nothing but a bar chart. Histogram depicts, it's again a prioritization tool which helps you understand the frequency of the defects. It's a bar chart which talks about the frequency of the number of defects. Now, looking into this particular histogram, if I have to eliminate the defects in the organization, in the project, I first would focus a lot on the analysis deficit. Then I will work on design gaps, and then I will work on development bugs. Control chart, this is very important. So control charts is a chart which is prepared to find out if my project is in control or not. Control charts are prepared with, each data is prepared. So whenever we are doing something, we have a control chart which can be prepared. To explain you the control chart is prepared with 3 standard deviations towards the upper side and 3 standard deviations towards the below side of the mean, of the average. So let me take a moment and try to explain this thing to you. Give me a moment here. So let's say the client has given you a contract, and client has told that you have to manufacture a nut bolt for my car. You are a supplier and you have to manufacture a nut bolt for the client, which has to be 6 inches long, plus or minus 0.03 inches, right? This is what the customer has given the specification. Then we have this, we need to ensure that 6 inches nut bolt is produced. This is what the client has told me. Now, what has to be done is when we produce the first lot, and after producing the first lot, we plot the data. We find out that first nut bolt which was produced is, let's say, the first nut bolt that I've produced is 5.9 inches. Then I have 6.01, 6.02, and so on. So this is how it would be. It's not exactly going to be 6 inches. No two parts, this is a globally accepted factor that no two parts are going to be similar. No two parts are going to be same. Whether you might be able to find out the difference with a naked eye or not, that's a separate thing, but no two parts are going to be exactly same. There has to be some inherent difference. Why? Because of the machine configuration, because of human factors, no two parts are going to be same. So there will be some variations from the 6 inches value, which the client is also accepting and saying that plus or minus 0.03 inches is fine for them. Average distance of each nut bolt, the value of each nut bolt from the mean, average distance of the of each nut bolt value from the mean, which is the average, is called as standard deviation, which is referred as sigma, right? 3 times standard deviation is referred as the upper control limit. 3 times standard deviation minus the mean value becomes your lower control limit, right? So this is your mean. Mean plus 3 standard deviation becomes your upper control limit. Mean minus 3 standard deviation becomes your lower control limit. This is how your control limits are defined. Now, once you have defined the control limits, then what you need to do when you're doing your program, when you're when you're producing the nut bolts, or when you're actually going and producing the nut bolts, or in a similar manner in the project environment, if let's say every day you were supposed to spend $100, it's not that every day you would be spending, you budgeted for $100 every day. Doesn't mean that you would be spending $100 every day. You might be spending $98 the first day, $102 the second day, and so on. You need to plot that data in this graph. Once you plot the data, you would be able to find out, is the variation is $102 if you have spent, should you take an action, or should you just leave it? It's okay. I mean, I was supposed to spend $100, I've spent $102. Should I be bothered about it, or should I not be bothered about it? What are the rules when I should be bothered about it, right? When I should be concerned that I think I'm spending too much, I need to control it. Sometimes it should be $102, sometimes $98. On an average, I'm spending $100. It's fine. It's no problem. Only when I have any expenditure which I'm doing in the organization which is above this 3 standard deviation limit. So let's say this is where $140, let's consider this in terms of the dollars. $60 was the minimum, 3 standard deviation. $140 was the maximum. And you have spent around $160 one day. Now this is above the 3 standard deviation limits. Anything above the 3 standard deviation or anything below the 3 standard deviation, you need to take an action, because looks like either you spend too much or you spend too low. Your mean is going to shift if this happens. Statistically, this should not have happened. Statistically, the variation should have been between $60 to $140, which was okay. If you spend too much, more than that, then you need to take an action and find out the reason. What happened? Why suddenly I had to spend too much? Right, in the project environment. That is one rule. Second rule is a date, second rule about the project is 7 consecutive points above or below the mean. So if you have 7 consecutive points, let's say 1 here, 2 here, 3, 4, 5, 6, 7. There's 7 consecutive points. It's not that towards one direction, but 7 consecutive points above or below the mean. You need to take an action to find out what exactly is happening. Why? Because your mean, the average, is shifting towards one side. It's deviating. Third rule is 8 consecutive points moving in one direction. So even if it is crisscrossing the mean, it's okay. But 8 consecutive points moving in one direction means, again, your project mean is shifting. From the exam perspective, these rules will come. What is the rule? 8 consecutive points moving in one direction, you as a project manager needs to take an action. 7 consecutive points above or below the mean, if that happens, you as a project manager needs to take an action. And third and final rule is anything above or below the control limits, you need to take an action, right? So this is how you decide when you need to take an action in your project environment. All right. All right, guys, let's do one thing. I think, this is the right time. We should take a break for today, for that half an hour break that we take. Let's take half an hour break and let's get back after half an hour and then complete the remaining part of the chapter. Before we go, before we go, Sherpa, Praveen, or do you guys have any question on what we have covered till now?
Nothing.
Nothing at the moment. Okay. These control charts tend to get slightly confusing. You don't need to understand how do you create the control charts. So just to make it more simpler, you don't need to understand how do you need to control the control, how do you need to prepare the control charts. This is generally prepared by your quality managers. All that you need to understand and remember is the 3 rules which I spoke about. What are those 3 rules? 7 consecutive points above or below the mean, 8 consecutive points in one direction, or anything above or below the control limits, right? That's when you need, as a project manager, needs to take an action. Just remember that, and that's sufficient from the exam perspective. All right, then let's go for the break and let's get back after half an hour. All right, guys?
Sure, Bhupinder.
Yeah, thank you. Hi guys, welcome back. Am I audible? Yeah.
I'm not sure if Praveen knows.
Yeah, Praveen, are you there? All right, I think let's give a couple of minutes for Praveen to join in, and then we will get started.
Sure.
Hi, Praveen, are you there? Are you back? I guess we are only waiting for Praveen. Rest two have joined, so we are just waiting for Praveen now. Is that Praveen? Praveen, you have joined, or who's just joined now?
Yeah, I have joined
Okay,
Bhupinder. Yeah.
all right, perfect. So let's get started. We have everybody back now. Let's get started once again. Before we went on break, we were talking about the control charts. Now, control charts, as I said earlier, you are the project managers, right? You would be project managers, not the quality managers. You don't need to be aware of how to prepare the control charts. This is a big topic. This topic of control charts itself is covered more than, is covered in more than 1 or 2 days, which we do it in the Six Sigma session. That is for the quality guys. From your perspective, your objective is to understand how to read the control chart and when to take an action, right? This will be prepared for you by somebody else. This will be prepared for you by your quality manager or your quality guys. They will prepare it for you, but you need to be able to understand how to read these control charts. So to read the control charts, always remember from the exam perspective, exam doesn't check that if you know how to prepare these control charts. Exam checks, do you know when to take an action? Do you understand how to read the read the control chart and when to take an action? Sorry. So yeah, that's what the exam checks. Now in the examination, from the exam perspective, there are only three rules. If you see anything above or below these limits, these are called as the control limits. Anything above this top line, right? If let's say you have a data point here instead of this red data point here, if you have above these control limits or below these control limits, you as a project manager need to find out the reason, because it should not have happened. Ideally, from statistics perspective, why? Let me just give you the reason behind it. From statistics perspective, 99.97% of the data is always supposed to be between the limits of 3 standard deviation, upper side and the below side. Right? So when 99.7% of the data is supposed to be within this, that means majority of the data is supposed to be within these limits. Why do we have anything beyond that? It cannot be a common variation. It has to be something special which has happened. That is why we take an action. Second is, if we have 7 consecutive points above or below, in this situation, we have, let's say 7 consecutive points, we don't see it over here though. 7 consecutive red dots above or below the mean of the chart. If you have 7 consecutive points above, that means there is something happening in the project and your mean is shifting. That's when you need to take an action. And the last one is 8 consecutive point moving in the one direction of the project. That is when you need to take an action, right? Just remember these three rules, and you should be good from understanding the control chart perspective and from the exam perspective as well. All right, let's move ahead. Next is the scatter plot. Scatter plot is something about which talks about the relationship between two variables. Let's say you want to find out if there is any relationship between TV screen size and the price. So the price, when it goes up, we have seen that the TV price is going up. And do we have any relationship if I want a higher, bigger size, bigger screen size TV? Does that mean I need to shell out more money? I just need to find that out. When I plot the data of all the TV, different screen size and their prices as well, I find the line going up this way, the second chart. When the line is going up, this indicates there is a positive correlation. Now this slide should be up in your screen as well now. When the line is going up, the second chart which says positive correlation, this indicates when or this proves my hypothesis, saying that when the prices of the costlier the TV, it should ideally have bigger screen size as well, right? So that's what it is proving my hypothesis. Previous one, if let's say between the two variables, you see when you plot the data and you find the line going down, that means it is negative correlation. And when there is no line appearing, that means it's no correlation between these two variables. If I have to share another example of this, let's say we want to find out, before a baby is born, the doctor predicts the weight of the baby, right? We want to find out if the predicted weight of the baby by the doctor is completely related with the actual birth weight of the baby. So we gather the data, we plot the data into the graph, we input the data and prepare the scatter diagram, and the line shows that there is a line which comes up and that is going up towards the upper side. It prepares a line which is going up. This indicates a positive correlation, right? That means doctors are pretty accurate. They are, even though there might be a little bit here and there, they might not be able to completely accurately predict, but same point of time, it's very close to the actual birth weight, right? So that is a positive correlation. Negative correlation means one variable going up, other variable going down. When one variable goes up, other variable goes down, right? For example, wheat in tons. In this example, when the when there is a higher production of the wheat, then the prices goes down, right? When there is a lower production of the wheat in tons, the prices goes up. It's a negative correlation, right? So that's about scatter diagram. The diagram is to find out the correlation between two variables. Benchmarking is comparison of apples to apples. So we need to compare the, we want to compare two variables and we want to find out the relationship between two variables. That's again when we do benchmarking. This involves comparing the planned process to the already existing use process. For example, now let's say your friend comes to you and says that please help me set up a factory. This factory is going to manufacture the mobile phones, or this factory is going to manufacture the tires for a car. Now, when you've set up the factory, you can always go ahead and look at the factory which is already successful. You can go and check out over there and find out if your factory which you're setting up is related to the other factory, is doing, is having the similar kind of machinery, the layout is similar. The previous existing factory becomes a benchmark. Another example would be one of your friend has a successfully running restaurant business, and another friend of yours asked that I want to I want to create another restaurant and I've taken a franchisee of your friend. So please help me set up his branch in another location. Now in that situation, again, the existing restaurant becomes your benchmark, right? The theme, the color scheme, everything becomes your benchmark. Design of experiments is the next one. So design of experiments is, let's say every day I travel to office. So when I'm traveling to office, I go in a car and my office is far. So I take around 1 hour, 15 minutes to reach office. Now, every day going to office would mean I'm spending some amount on gas. I'm spending some amount on petrol. This amount is very important for me because, normally in India we are penny wise. We don't want to be we don't want to be spending extravagantly, and we just want to control. So for me, the mileage of the car is very important. I want to ensure that the mileage of the car is controlled and it is not higher than, I'm getting the best mileage of the car. So I speak to some of the experts. The experts tell me that, okay, if you drive the car in, one of the experts, he says if you drive the car at 55 miles per hour, you're going to get better mileage. Another expert says that if you drive at 60 miles per hour, you're going to get better mileage. Now I'm confused. I don't know, 55 miles or 60 miles, but I have these two variables now. Another expert says that if you drive it at 32 psi, the tire pressure, you're going to get a good mileage. If you drive it at 35 psi tire pressure, you're going to get better mileage with less of friction. Again, I'm confused. I don't know 32 psi or 35 psi. Traditional approach would be change one variable at a time and conduct the experiment to find out which gives you the best mileage. What if tire pressure doesn't have any relation with output? Unnecessarily, I would be controlling it, right? If doing it with the traditional approach. Where I change first the tire pressure and combine it with, let's say, 55 miles per hour. Then I change the tire pressure again and combine it with, let's say, 60 miles per hour. That's a traditional approach. But what if one of the variable which is given to me doesn't have any relationship with output? Design of experiment helps me conduct the experiment the traditional way, but analyze the experiment to find out if all the variables that I've using which I've conducted the experiment, does it make sense to control all of them? What is the best mechanism? What is the best combination using which I can get the best mileage, right? So that's what design of experiment helps me do. Statistical sampling is, let's say I want to find out the average height of adult men in United States. Now, if I have to do that and I have to do it completely accurately, then I have to go and ask each and every individual in, each and every adult man in the United States, get his height and then calculate the average. It's just too cumbersome of a task. It's going to take me a lot of money. It's going to take me a lot of time. Instead of that, if I can give the results with plus or minus 1 inches variation, then I can go ahead and measure the sample. Instead of looking at the entire population, if I can get very close results by looking at just 100 or 200 people, that is better, right? That's going to involve lesser cost, lesser time. That is the power of sampling. And that's where we do statistical sampling. How much sample to pull? It doesn't matter at the moment. The sample size and, sample size is calculated using multiple formulas which your quality manager would give. However, the sample always has to be random and it has to represent the population, right? It has to always represent the population. Just a second, guys. I'm going to put you on mute for just 2 minutes. Just a moment. Right, sorry. There are two types of sampling that we do. One is the attribute sampling and variable sampling. Attribute sampling is when you have the data in yes or no, low, medium, high, very low, low, medium, high, very high. That kind of data, if it's structured, even the CSAT score, 0, 1, 2, 3, 4, 5, right? All of that is attribute sampling. Variable sampling is where you have the data divided in data which can be divided in decimals and has a unit attached to it. Unit can also be a percentage, that's not a problem, but otherwise a pure unit is meters, liters, miles per gallon, kilometers per liter, and so on, right? All the hours, seconds, all that becomes your unit. So that is a variable sampling. Just from your understanding purpose, the sample the sample required for a variable sampling The data required for variable sampling is far lesser than the attribute sampling because we get much more precision in the data. All right, so there are a couple of more quality planning tools which we have, which can be used to, which can further be used. One is brainstorming. I can, of course, brainstorm with my team members to find out what is the root cause. I can just speak to my team members and find out, okay, what is the root cause? Why do you think this error has happened? What more we can do to control these kind of errors? Force field analysis. Whenever we bring in a change in organization or in the project, there are certain forces which is against the change, and there are certain forces which is in favor of your change. Our job as a project manager is to ensure that more forces are there which are pushing my change towards the positive outcome, not resistive. They are driving the change. So that would increase the chance of success of the change, right? So that is the force field analysis. Nominal group technique is when we brainstorm the session, when we conduct the brainstorming in a smaller group. Maybe in your team you have 5 SMEs out of 50 people that report to you. Conducting the brainstorming session with them, just the SMEs, becomes a nominal group technique. So that there is not too much of deviation because of inexperience of the new resources. Your brainstorming doesn't get deviated. It's completely focused. So that's why you at times would conduct a nominal group technique. Then you have the quality management control tools, which can be used to link and sequence the quality activities. Let's talk about a couple of more things, which is quality management plan versus the project improvement plan. Quality management plan is how would you manage the quality? How would you ensure that the quality is delivered to the client? What is quality? Conformance to the use, conformance to the requirement, right? How would you ensure that the quality is delivered to the customer? Quality management plans defines how the organizational quality policies and the project quality objectives will be implanted and achieved, right? Both from the organization perspective and from the customer perspective. Process improvement plan, on the other hand, is today I'm conducting a project using one process. Maybe there are certain improvement areas in the process itself. Today I'm using waterfall, I want to use agile, right? Today I'm using agile, but the agile is not implemented in true sense. I probably can improve it further. Maybe when I was using Agile, I found certain areas where the documentation was not completed, so I can refine Agile to make it more suitable to my environment. Whatever it could be, improving the process of conducting the project is process improvement plan, right? Where you improve the process itself of conducting projects. It's not just about your current project, it's about overall improving the predictability of the project by improving the processes to conduct the project. Quality metrics, this is how it looks like when our quality team, they produce the data, they send out the data to us. This is how their reports look like. Quality checklist is a checklist where the customers, our quality guys, they check if the checklist was followed. For example, the example given over here is, did you follow the standard greeting? Did you identify the caller, determine the reason for the call, and so on. A checklist is very important for at times to find out if the procedures have been followed or not, right? Next is perform quality assurance. We perform the quality assurance to ensure that what is quality assurance? Quality assurance is about if we are following the current procedures or not. Now there are a couple of terms which I've used: quality control, quality management. Quality control is about ensuring that whatever we are doing today, it is in line with what the customer really wanted, and we are following the procedures and policies of the organization. Quality audit specifically is only about the procedures and policies of the organization. We do quality audit where the quality guys comes and says that your documentations are complete, your records are complete. They give their recommendations. If they're not concerned about the deliverable which you have for the client. They are concerned about if you're maintaining the records, if you're maintaining the documentations, and if it is in line with the organization's policies and the procedures. That is quality assurance. Quality control is, which is completely related to what the customer really wants. It's related to quality check. QC guys who check, who build the test cases and validate if you have developed what the customer really wanted. Will it meet the customer's acceptance criteria or not? Right? So these are the two layers: quality assurance and quality control. Quality control sits at, it talks about the customer's requirement. Quality assurance talks about the organization's policies and the procedure, organization's requirement. So there are a couple of quality assurance tools and techniques which can be used. One is affinity diagram. Affinity diagram is, let's say, I brainstorm I brainstorm and come up with various ideas or the problems. When I want to combine those different ideas and try to find out the category in which those ideas belong, I create the categories that would become the affinity diagram, how these are related to each other. Process decision program chart. This is breaks down the task into tree hierarchy. It is towards, it's a tree hierarchy that we have broken down to identify the low level risk and issues. Interrelationship, where we are trying to find out the relationship between different ideas or different problems to find out, define the relationship between complex situation to solve the complexity, how they're related to each other. Tree diagram is very much similar to PDPC. It's just that it's depicted in a little different manner. It's again breaking down into granularity, which helps you think at the finer detail. It's very similar, but then towards the right-hand side from the pictures which is given out, if you see PDPC is more of a decomposition and a tree diagram is more of a branching. Prioritization metric is each item is given a weight to identify and focus on items which are more important in nature. And then finally, we have the matrix. This is again a prioritization diagram, but again, prioritization, you have some weightage given out. Here, the weightage is not given out. Quality audit, QA guys, they identify if you're following the procedures and the policies. Process analysis, if my process that I have for the project, the process using which I'm conducting the projects is effective or not. Can I make improvement on that? That would be process improvement. First process analysis is to find out the gaps. Plugging those gaps would be process improvement. Eventually, I would need to control the quality. To control the quality, I need to inspect. I need to inspect if, I need to do the audit and inspection to find out if my quality is effective or not, right? So this is all about the quality management structure. This is entire about the quality chapter. Most important things which you need to remember, the three gentlemen, the rules or the theories which they published or they gave Juran 80-20 rule, triology, then you have the Edward Deming's PDCA, all those triology has to be remembered. Control chart is very, very important, in which the three rules you have to remember. That is pretty much it, what comes from this chapter. Remember these things, right? So that's it from the quality chapter perspective. I think we are done for today. We can close it over here, and then let's meet tomorrow. I'm going to upload this session again into, into the. I'm going to send out the email with the session. Do you have any questions? If you don't have, then we can close it for today. If you have any questions, then I can take it. Yeah,
I have a question. Quick question. Actually, do we need to read the Rita book also?
No, not really. I recommend only to go through the book which has been given out to you by Skill Logic. That is a sufficient book. I don't recommend you to go through the Rita Moody book. That is not required. Just go through that book and go through the mock exams of Skill Logic, and you will be ready for the exam.
Okay, so anyway, I am reading the 5th edition, so that and this one should be okay, right?
Go through this one, and then the 5th edition, you just brush through it, because there are some things in the PMBOK 5th edition which are, which are not detailed, which are not given, there are certain things in 5th edition which are left out. 5th edition PMBOK doesn't cover everything which comes in the exam. All
So
those
you
things which,
mean
yeah.
what is the book you have PMP 5th edition? That's the book you are recommending to go through?
I'm recommending PMBOK, you brush through it. What you need to go through is the book which has been given out to you by Skill Logic.
Is it that one which has 394 pages?
Yes.
Okay, got it. Thank you.
Welcome. Any other questions, Praveen, or anyone else? Any other questions that we have?
Bhupender, a
Yeah.
small question.
Mm-hmm.
So we don't have any calculations or anything as part of this chapter?
No, not at all. Not at all. Just the CBR and BCR you need to remember. And that is also not the calculation. Just remember the rule about CBR and BCR. That is benefit to cost relationship. When your benefit has to be higher than the cost. That's the only thing which from the mathematical perspective, but that also you don't have to calculate it as such.
Okay. No, because you mentioned about UCL and LCL and all that stuff,
No,
right? So I was
that,
just thinking, do we have calculations?
you don't have to calculate that. That's why I was paying a lot of, I was speaking about that again and again and saying that these control limits are not calculated by you. You won't need to calculate that. I just explained it, but otherwise this will be given to you by your quality team. Our perspective is we just need to understand how to read it.
Okay, got it.
All right. All right then, guys. See you then tomorrow. And have a great day ahead. Bye-bye. Take care.
Yeah, bye.
Thank you.